Let's look at some simple stoichiometry calculations. Go to page 9 of 20,
Yeah.
the next page.
What's what's stoichiometry?
Where stoichiometry involves some of the simple calculations we do in chemistry to determine certain ratios of masses, moles, volumes, and what have you.
Oh,
Yeah, there are things you already know, but I just want to introduce them. For
yeah.
instance, what's an element, by the way?
The element is like made up of atoms with the same number of protons.
Okay, once they have the same number of protons, they are of the same element. They may have
Yeah.
different number of neutrons. They may have different number of com- um, they may have different nucleon numbers on different mass numbers. In that case, we
Yeah.
say they are isotopes,
Isotopes. Yeah.
but they are still the same element. No, so what's a so element once they have the same number of protons, that's the same atomic number,
Mm.
same element. Okay, so what are compounds?
Two or more elements are chemically joined together.
Okay, chemically joined together. They always chemically joined together because if it is a physical combination, you will have a mixture, not a compound. Okay,
Yeah.
you know a mixture can be separated using a physical means like
Yeah. Like
boiling, evaporation, and what have you.
ionization, all that.
All right. So what's a molecule?
The unit of an element or a compound that can exist on its own.
Okay. For instance, look, let me use this to illustrate that a molecule is the unit of an element or a compound that can exist on its own. O,
Yeah.
O, which is an oxygen atom, cannot exist on its own. Oxygen always forms a molecule of two atoms.
Okay.
So we say oxygen is a diatomic molecule. Diatomic, like two. You know when we say di, like that dichromate, carbon dioxide. You know something
Yeah.
nitrogen dioxide and so on, or dinitrogen oxide. So all of those things are di means two. So oxygen exists as a molecule with two atoms.
Mm.
So O alone is an atom.
Yeah.
O2 is a molecule. You
Molecule.
can
Yeah.
find it existing as O2. H2O is a compound and it can exist like this as a molecule.
Yeah.
So now when I now write like what I said I was going to explain to you, if I write 3H2O, it means I have three molecules of water. If I write 5O2, it means I have five molecules of oxygen. Okay?
Mm.
All right. Okay. I remember the previous slide I explained to you that, for instance, copper nitrate, how you can get copper nitrate. Copper has a valency of,
Two.
I mean, copper 2 nitrate. Copper 2 nitrate means it has a valency of 2 plus. Nitrate has a valency of 1 minus. So when they combine, they swap valencies. 2 comes to
Yeah.
nitrate, while 1 comes to copper. So you have Cu with a 1. We don't have the need to write the 1. Open a bracket, NO22. So if I have iron 3 carbonate, the same thing.
Mm.
Iron has 3 plus because it's iron 3. You can also have iron 2, iron 1. So carbonate has 2 minus. So they combine. As usual, 3 comes to carbonate. 2
Yeah.
goes to iron. So you have Fe2, then open a bracket, CO3, and then close the bracket 3. Alright. Now, next page. Go to the next page.
Yeah. Oh yeah. I'm good with relative atomic mass. I
Pardon?
like. I'm good with relative atomic mass.
You're good with relative atomic mass, so we wouldn't waste time on it. Just a quick review. You
Yeah.
know, when you have Al2, CO3, exactly what I. Okay, can you still do this? let's look at something that is a little bit Al2CO3.5 water. That's how we pronounce it.
Dot. Why is there a dot there?
Yeah, some of them are hydrated. So this is how we call it, hydrated aluminum carbonate. First of all, this one alone is what?
You do 27. Like.
So what's the name of this? What's the name of this one I'm circling?
Aluminium oxide.
No, CO3. What's CO3?
Aluminium carbon dioxide.
CO3 itself is called carbonate. Remember where I explained all that? Can you go to page 7 to remind yourself of that?
Oh, aluminium carbonate.
Carbonate. CO3 is carbonate. So that should be aluminum carbonate. So this alone is aluminum carbonate.
Yeah.
With water, we call it hydrated aluminum carbonate.
Oh.
They are usually together, so they will have a total relative molecular mass consisting of that of aluminum carbonate alone and the 5 molecules of water together.
Yeah.
So first of all, you will do aluminum. The relative molecular mass of aluminum is 27, so you do 27 times 2, isn't it?
Yeah.
Plus,
And then 12 plus 16 times 3.
or
But then
to
times that all that by 3.
or multiply all that by 3.
And then
You also do this one.
plus 5 times 1 times 2, which is 2, and then plus 16.
Yes. So 1 times 2, then plus 16. After that,
Yeah.
you multiply the answer by 5. This gives 54. This gives 180. And this
Yeah.
gives 90. So the relative molecular mass is adding all, isn't it?
Yeah.
Which gives us 324 grams. That's the relative molecular mass of aluminum carbonate .5 water, or hydrated aluminum carbonate.
Okay.
I think that's cool.
Yeah, that's fine.
That's relative molecular mass. Okay. Sometimes you may need to know the definition. The relative atomic mass is the weighted average mass of naturally occurring atoms of an element on a scale where an atom of carbon-12 has a mass of exactly 12 units. I don't want to go into the details. Relative simply means it is measured with respect to carbon. If we give carbon-12,
Is it always carbon?
yes, carbon is the basis for that comparison. It is measured with respect to carbon, whereas carbon is given 12. The other ones are given with respect to how they weigh compared to carbon. So for instance, magnesium, which is I think 24, you don't need to memorize all those values. It's provided in the formula table. Magnesium is 24. Since carbon-12 is 12, so how massive is magnesium compared to carbon? Twice. Okay, so it's all with respect to carbon. That's why it is called relative. You know, when we say something is relative, it is measured with respect to something in comparison. Okay.
Yeah.
The basis of comparison is carbon-12 that has 12 grams or 12 units. So every other thing will be measured with respect to it. Okay, let's move on to, this is part of what we just did. If you look at this, magnesium nitrate 6 water.
Yeah.
Go to the next page. Okay, you are there already. Magnesium nitrate 6 water is the same thing you do to get that. Okay,
Yeah. Oh yeah.
you can do all that.
Mm.
All right, exactly the same thing we did. So go to the next page. We need to move faster so that we can cover more. Let's go to empirical formula. Do you remember empirical formula?
Is there like another name for it?
And well, it's usually the name we give it. The empirical formula is like the unit formula, like what we were talking about when you had C2O4 and I asked you to reduce to the lowest term, and then you got what? CO2. So the empirical formula is like the unit formula. It may have what we call molecular formula. Now let's use this as an example. A,
Are you sure we do this?
no, we haven't. I'm
No,
doing
I'm
it.
saying like, are you sure I'm meant to do this?
Yes, please. Yes.
Wait, is this I think this is something to do with moles.
Yep.
Yeah, but it's called differently in like I don't know school.
Oh, okay. Let's run through it so that we can move to something and don't.
Yeah, because I've seen this before. Like yeah, I've done this before.
It might just be something you already know. But let me just
Yeah.
quickly remind you of how to go about it. For instance, it says a compound of carbon and hydrogen contains 85.7% of carbon, 14.3% of hydrogen by mass. Deduce the empirical formula of this hydrocarbon.
What does deduce mean?
Just find, obtain,
Oh,
obtain. In other words, it could be calculate or determine. All right, these are always provided in the formula in the periodic table. Carbon is
okay.
12, oxygen is 16 or 16.0,
Yeah.
it doesn't matter. So the first step, right,
Yeah.
is to write out their percentage by mass or percentage by whatever.
Yep.
Carbon is given as what?
85.7%,
And
hydrogen is 14.3%.
okay, please let me just give you a question that might look a bit different so that you won't be asking, what about the other one? If I told you an oxide of magnesium contains 78% of magnesium,
Mm.
I don't have to give the one for oxygen.
No, you don't. You just do 100 equals 78. It'll be 22.
22 years. So if
Yeah.
I just, because it's an oxide of magnesium, meaning it only contains magnesium and oxygen, isn't it?
Yeah.
Since magnesium is already 78%, oxygen, which is the remaining one, will be 100 minus 78, which, so
Yeah.
oxygen will be 100 minus 78, which is 22%. So I don't need to
Yeah.
also add that. All right. So sometimes you will get a question like, don't be asking, what about the percentage of the other one? Just know that it's included. All right. So the first step is write out their percentage composition, and then you divide the percentage by their relative
By
atomic
the
mass. Carbon is
okay.
12, oxygen is 16. What's that?
And then you divide the answer by itself.
Hold on. Oh, that's about carbon and hydrogen. Carbon, hydrogen. Hold on. Oh, it's just about carbon and hydrogen. A compound containing carbon and hydrogen. Okay, sorry, this is about carbon and hydrogen. Why did they give oxygen? That's a mistake. It's supposed to be carbon 12. Hydrogen is supposed to be given here. Do you understand?
I don't. Wait. What do you mean?
It's carbon and hydrogen, but we mistakenly gave carbon and oxygen. Look at the question.
Oh yeah, the atomic masses. Yeah.
Atomic mass of hydrogen that should have been given here. It's okay. Atomic mass of hydrogen is 1 anyways. All right. Okay, so like I said, you divide each percentage by its atomic mass. All right. Are you still there? All right. So for instance, that of oxygen is given. So like I said, the first step is you note their percentage composition, and then you divide the percentage by the relative atomic mass. So 85.7 divided by 12 for carbon. Hydrogen, you have 14.3 divided by 1, because that of hydrogen is 1. Are you there?
My Wi-Fi like just went, but it came back now.
Alright, that's fine. So I was explaining the second step.
Yeah.
The first step.
Yeah, I get that, but and then I get how you have to divide by the lowest, like you know how the other one, like the L.
Alright, so after dividing each percentage by its atomic mass, you have values. Like the one for carbon will be 7.142, the one for hydrogen is 14.3. What you need to do is now you divide by the lowest figure. Between 7.142 and 14.3, which one is lower? Obviously 7.142. Are you there?
Yeah.
So you divide each of these by 7.142. So what I'm basically saying is each one divided by 7.142. Each one divided by 7.142. 7.142, and then you're basically reducing it, finding the ratio of one to the other. That's like what we're doing. So this we give 1, isn't it?
Yeah.
Why this one gives 2? Okay. So the empirical formula is all these things you got. For carbon is 1, for hydrogen is 2, so it becomes CH2. C1 for carbon, H2 for hydrogen.
Yeah.
So it becomes CH2. Do you remember anything like this now?
Yeah.
All right. Let's. I would have asked you to do another one. Let me see. Let's look at this one now. Look at number 9. Are you reading it out? Can you read it out?
The composition of biomass of a hydrocarbon is 10%, hydrogen and 90% carbon. Deduce the empirical formula of this hydrocarbon. C equals tau, H equals 1.
Okay. So as usual, we do 90 divided by 12 for carbon.
Yeah.
Hydrogen we do 10 divided by 1. So
and then you divide it by the
smallest.
Like lowest.
So when we did for 90 divided by 12, we got 7.5. 10 divided by 1, we got 1. So the thing about this one I need you to take note of, when we divided 7.5 by 7.5, we got 1. But when we divided 10 by 7.5, we got 4 over 3.
Yeah.
Please leave it in fraction. It's better to leave it in fraction, not decimals.
Okay.
So 4 over 3, how will you now write the formula? We have 1 ratio 4 over 3 if we have 1 ratio 4 over 3. You simply cross. You see, 3 can go to here now, isn't it?
Oh, because you cross multiply.
So it becomes 3 ratio 4, isn't it?
Yeah.
But when you're cross multiplying, you need to be careful. 3 to multiply 1, so it becomes 3 ratio 4.
Yeah.
Is that clear? This is the same thing as 3 ratio 4. So what I'm saying is 1 ratio 4 over 3 is the same thing as 3 ratio 4.
Okay.
So what will be the empirical formula?
It will be C3H4.
H4. Now, the next thing is what we call molecular formula. Molecular formula is also easy. What you do to get molecular formula is, first of all, you'll be given the relative molecular mass of the compound itself. Like, read out this question.
A compound has an empirical formula CH2Br. Its relative molecular mass is 187.8. Deduce the molecular formula of this compound. Br equals 79.9, C equals 12, H equals 1.0. So.
Okay.
Do you first know relative atomic mass?
The relative atomic mass is given for the entire compound.
But look, they work out something else
What did he say?
Because look, you know how it said, find the and the empirical formula mass. That's the same thing as the relative atomic mass, isn't it?
No, this is the relative molecular mass for the molecular formula. Okay, so that you don't get confused, let me explain it properly. The thing you do is you find the relative molecular empirical formula mass.
Yeah.
Read it out. Step 1.
Find the empirical formula mass. 12.0 plus 2 times 1 plus 79.9 equals 93.9.
You know how we got that? Because carbon is 12, hydrogen is 1, Br is 79,
Yeah,
isn't
so
it?
that's basically the relative atomic mass.
Yes, that's the relative atomic mass for that
So,
empirical formula.
so you know the 187.8
Is
is that for
the real thing
yeah.
when it was not reduced to the lowest term. Do you understand? That was before it was reduced to the lowest term.
Yeah,
Because
like,
the empirical.
when you look,
Yeah, go ahead.
when you look at it here, you can like simplify that to CH2Br.
Exactly. If you simplify it, it will actually give you CH2Br, which is the empirical formula.
Yeah.
But this is the real molecular formula. All right. So, like you said, the first step is to find the empirical formula mass. That's the formula mass of this empirical formula, which of course is C is 12 plus 2 times 1, because there are 2 atoms of hydrogen, plus 79, and that gives us 93.9, isn't it? So the next step is divide the relative molecular mass by that
one.
the value, the empirical formula mass. Relative molecular mass 187 divided by that empirical formula mass 93.3. So 187.8 divided by 93.9, that gives 2. So you just multiply 2 by each of them, that's all.
And then you just find the.
So that, I mean, 2 times. You just do what?
It basically gives you the molecular formula.
Yes, whatever you get now is the molecular formula. But if you simplify it, you get the empirical formula.
Yeah.
So this is the answer, which is the molecular formula we're asked to find. Okay. All right, please. I just need you to do one, and then we. Can you do this? Number 10. Yeah, question number 10.
Okay. Where should I do it? Next page.
Let me see. We can do it here. Let me clean this so that we can do it here, since I've already explained this cross multiplication. I've told you how to cross multiply, so let's solve it here.
Okay. Are you gonna write it or should I?
Since your pen is giving you issues, you can say it, then I will write it down.
Yeah. Okay. Let me just read it. The empirical formula and the molar masses of 3 compounds A, B, and C are shown in the table below. Calculate the molecular formula of each of these compounds. C equals 12, Cl equals 35.
Let's just do for A so that we don't waste time.
A.
This is C3H5. The empirical formula is C3H5, and the relative molecular mass is 82. So let's get the molecular formula.
Okay.
Bless you.
So, okay. But we're not given any percentages or anything.
Because we don't need it. We are not asked to find the empirical formula. Empirical formula is already given.
Actually, no. Okay. So first we should find the molecular thingy. So we do.
What? Say that properly. We should find what?
We should find the molecular mass.
The empirical formula mass.
Yeah.
We should find the empirical formula mass.
12 times 3.
Okay, that's the question A, right?
Yeah.
So question A would be 12 times 3
12
Ready?
times
A.
3 plus... Why did they give you... Oh. 12 times 3 plus H times 1 times...
Let me, okay, I should leave
5.
this. Okay, 12 plus 3 plus...
1 times 5.
Open a bracket, 1 times 5.
41. And then...
That gives what? 25. What does it give?
Altogether, that's 40...
41.
41.
Okay. That gives 41.
And then you do the 82 there, the thing that's given, divided by 41.
So the next thing is to do 82 divided by 41. And that gives...
Which is
2. So the molecular formula will be what?
2 times C3H5, which will give you C6H10.
We multiply each of those things by 2. So that will be C3H5 all multiplied by 2. Isn't it?
2, which will give you C6H10.
H10. All right. So that's basically it. All right. Before we look at another one, I wanted to be sure. Okay. Let me see. Okay, I think that should be it for that topic. We go to something else where we need to calculate some other things. All right, just a moment.
Can I go to toilet quickly?
Okay, please.